June 18, paper
Paper
3-2, right?
32. Yes, sir.
ओके एवरीवन, सो लेट्स बिगिन देन। सो हम अभी आज की क्लास में क्या करें, हम कुछ डिफिकल्ट क्वेश्चंस देखते हैं जो भी आप लोग डिफरेंट कॉन्सेप्ट्स पूछना चाहते हैं, डिफरेंट अगर कोई पास पेपर क्वेश्चंस हैं तो वो हम डिस्कस करें इस क्लास में। तो अभी अगर आपके 2-3 क्वेश्चंस हैं कोई पुराने पेपर से वो देख सकते हैं हम, फिर और फिर 2022 के पेपर से भी हम देख सकते हैं। कौन सा क्वेश्चन है? Abdullah, which question is that? Is it this one?
Yes, sir.
Okay. All right, so let's have a look at this. This is an implicit differentiation problem. I think you're confused about the second part. Is that correct? Or is it the first part?
Sir, first part.
First part, okay. This is June 2018, paper 3-2, question number 5. Okay, so let's try this. It says the equation of a curve is x squared into x plus 3y minus y cube equals 3. What you need to do is you need to find dy over dx. Okay, now this is a type of problem where y is not the subject. So when y is not the subject, what you have to do generally is you have to use implicit differentiation. Okay, now you have to use implicit differentiation to find dy over dx. Now let's see how we can do that. I'll just change the pen sizes quickly. Okay, so how do you differentiate this? It's going to become simpler if we simplify this equation first before differentiating, because otherwise we would have to apply a product rule on this whole thing. If we simplify this, it might become slightly simpler than this. Let's do that. Before differentiating, what I'm doing is I'm just multiplying these two terms, and that's going to give me x cubed plus 3x squared y minus y cubed equals 3. Okay, this is the simplified form that I get from this. Now, I can differentiate both sides with respect to x. Differentiate both sides with respect to x. Now, you do not necessarily have to write it down, but this is what you have to do. Now, what's the derivative of x cubed? How do you differentiate x cubed? It's a power function. You can apply power rule on this, right? Apply power rule on this and see what that gives you. X cubed, it becomes 3. You multiply by the power. X raised to the power 2, you subtract 1 from the power, right? And then you have to multiply with the derivative of the base. What's the derivative of the base? Derivative of x is just 1. So you can just leave it like this, or if you want, you can multiply by 1 here. Okay, it's not necessary to show that 1. You can just say that's 3x squared. But there's a reason why I'm showing this, because when you take the derivative of y, you need to make sure that you write down that the derivative of y is dy over dx. Now, let me explain what I mean by that using this. 3 is a constant. Constant remains as it is. X square y, that is a product. How do you differentiate products? You have to apply product rule. So what you do is you say, this is u and this is v. Okay. And now the derivative of this is going to become uv dash plus vu dash. Now x square remains as it is, so u remains as it is, into derivative of y. What's the derivative of y? Sorry, x square remains as it is. Derivative of y, what's that? Now, this is an important thing to remember when you're doing implicit differentiation. When you differentiate x with respect to x, what's the result for that? Derivative of x with respect to x, dx over dx, that is just 1. Derivative of x with respect to x is just 1. However, when you differentiate with respect to x, y, when you differentiate y with respect to x, what does that become? That becomes dy over dx. And that is exactly what you're looking for. This is not going to be 1. Derivative of y with respect to x is going to be dy over dx. Derivative of x with respect to x, that will be 1. Okay? So what's the derivative of y here then? That's going to be dy over dx. So it becomes x squared into dy over dx plus derivative of u and v as it is. So v as it is, that means y as it is, into derivative of x squared. What's that? That is 2x. That's the differentiation of the second term, minus y cubed. What's the derivative of y cubed? Again, it's a power function. You apply the power rule on this. Power gets multiplied. Subtract 1 from the power, it becomes 2. And then you have to multiply by the derivative of the base. What's the derivative of y with respect to x? That is dy over dx. Now, on the other side, it's a very common error that you have 3 here. You leave it as 3. Remember, we are differentiating both sides with respect to x. So what's the derivative of 3 with respect to x? That is going to be 0. So on the right side, we would have 0 eventually. Now, let's simplify everything. This gives us 3x squared plus 3x squared into dy over dx plus 3 into 2, that is 6, into xy minus 3y squared into dy over dx. Now the differentiation part is over. Now it's just about making dy over dx the subject. Now it's simple algebra. Okay. Now, what does this become? You have 3 in every single term. You divide the whole thing by 3. What does that leave you with? That will simplify things for you. This will be x squared plus x squared dy over dx plus 2xy minus y squared into dy over dx. Okay, now let's take dy over dx common from these two terms. What does that leave us with? Dy over dx. Keep these terms on the left side, take the other terms on the right side. They will give you minus x squared minus 2xy on the right side. Now from these two terms, we take dy over dx common. What are we left with inside? X squared minus y squared. And now you can just divide this thing on the other side, and that becomes dy over dx equals minus x squared minus 2xy divided by x squared minus y squared. And that is your derivative of y with respect to x. That is dy over dx. That's what we were looking for. Now, in the question, they asked you to prove it to be in a slightly different form, as in they wanted the final result to be slightly different. And that final result is x squared plus 2xy divided by y squared minus x squared. Okay, that's what they wanted you to prove. And you are getting minus x squared minus 2xy divided by x squared minus y squared. Now, what's the difference between them? You can see, if I take minus common from the numerator, that leaves me with x squared plus 2xy in the numerator. And then what I can do is I can just multiply the minus from numerator with the denominator, right? Because if you have, for instance, minus 3 over 4, that's the same thing as saying 3 over minus 4. These two things are equivalent. Okay, so this minus I can put in the denominator as well. And if that gets multiplied with the denominator, that becomes x squared plus 2xy divided by y squared minus x squared. Okay, and that's what we wanted to prove. Another way to do such things is when you want to change the signs in both the numerator and the denominator. Another idea you can use is you can say, let's multiply the numerator and denominator, both of them, by minus 1. We can do that, right? We can multiply, because minus 1 over minus 1, that's just 1, right? So I can multiply something by 1, it does not change anything. Now, if I multiply the numerator by minus 1, that gives me x squared plus 2xy. And if I multiply the denominator by minus 1, the signs change and it becomes y squared minus x squared. And that will be even quicker. You could just write it directly after that point, right? So we can convert it to this form like this. And that's our final result. That's dy over dx. That is what we had to prove in the first part. Now, once you have the derivative, once you have dy over dx, what did they ask you to do in the second part? Now they're saying, hence find the exact coordinates of the 2 points on the curve at which the gradient of the normal is 1. Now this is a standard type of problem that they ask after implicit differentiation. And the second part, they would ask you to do something using that derivative. Now in this case, they say, find the coordinates of the 2 points at which the gradient of the normal is 1. Gradient of normal is supposed to be 1. Now, how do you find gradient of normal? This is the gradient of the curve. This is the gradient of the curve. dy over dx represents gradient of curve. Now, what we can do is, we can say, if the gradient of the normal at that point is 1, let me write that on the side. If the gradient of normal at a point is 1, what about the gradient of tangent at that point? What would that be? Gradient and tangent and normal are supposed to be negative reciprocal of each other. So this is 1. Gradient of tangent would be negative reciprocal of 1. That means minus 1 over 1. That is minus 1. So gradient of tangent is minus 1. Okay. Now, if the gradient of tangent is minus 1 at that point, that also means that the gradient of the curve at that point, gradient of the curve at that particular point, that is also equal to minus 1, right? Because gradient of a curve at a particular point is the same as the gradient of the tangent at that point. So all we have to do is put this derivative equal to minus 1. Put the gradient of the curve equal to minus 1, and that will give you an equation. What does this turn out to be? X squared plus 2xy divided by y squared minus x squared. That equals minus 1. Okay. And now this is an equation that you've got. Let's simplify this. This becomes x squared plus 2xy equals minus into y squared minus x squared. That becomes minus y squared plus x squared. Now x squared and x squared on both sides, they will kind of get cancelled. Let me actually just take everything to one side, and that will give me x squared plus 2xy plus y squared minus x squared equals 0. X squared and x squared get cancelled, and we are left with 2xy plus y squared equals 0. Now this is one equation that we have in terms of x and y. In order to find that point, we need another equation. What's another equation that we've got? This point that we're talking about that also lies on the equation of the curve. So this is another relationship between x and y. Let's write that down here. X squared into x plus 3y plus like minus y cubed equals 3. This is another equation that we've got. So we have two equations in terms of x and y. All we have to do is solve these two equations simultaneously, and that is going to give us the values of the two coordinates for those 2 points. Okay, so how do we solve these two equations simultaneously now? From the first equation, what we can do is we can take y common. Remember, never divide by a variable. Never divide by a variable. So in this case, you can't do this, that if you take y common, for instance, or just like this, if you divide the whole thing by y on both sides, that will not be the correct way to do it. Why? Because what if the value of y was equal to 0? You'll be dividing by 0, and division by 0 makes the function undefined. So you can't divide by 0. What's the proper way of solving equations like these? You take y common, and that leaves you with 2x plus y inside. That means either y equals 0 or 2x plus y equals 0. These are the two possibilities that you've got. Okay. Now, we are getting y equal to 0, or we are getting y equal to minus 2x. Now, these are two things that you would go and input in that other equation. Let's simplify that other equation a bit first. We already did that above. Let's do that again. This is going to be x cubed plus 3x squared y minus y cubed equal to 3. Now, in this equation, we would have to input y equal to 0 once, and then you'd have to input y equal to minus 2x. And that's going to give you the two possible values for x. Let's do that. If you put y equal to 0, what does that give us? X cubed plus 0 minus 0 equals 3. X cubed equals 3. You take cube root on both sides, and that's going to give you x equals cube root of 3. Okay, that is what we are getting from this. Now, the x coordinate of one of the 2 points is cube root of 3. The y coordinate, in fact, is already 0. So we have 1 point, and that 1 point is cube root of 3 and 0. Okay. And then if we put y equal to minus 2x, what does that become? X cubed plus 3x squared into minus 2x minus 2x whole cube equals 3. Let's simplify everything. It becomes x cubed minus 6x cubed minus, what's the cube of minus 2x? The minus sign will stay there. So it becomes minus 8x cubed equals 3. Now let's simplify everything. X cubed minus 6x cubed plus 8x cubed equals 3. And that gives you 9 minus 6, which is 3. 3x cubed equals 3. X cubed equals 1. And the value of x turns out to be 1. If x equals 1, what about the corresponding value for y? That is going to be minus 2. So this is another point that we're getting. Now we just look at the question statement. If both of those points are possible, yes. So it says find the exact coordinates of the 2 points. So we needed 2 points, and we've got 2 points. These are the final answers that we were looking for. These are the 2 points at which the gradient of the normal is equal to plus 1. Is that okay?
Yes, sir. Sir, I wanted to ask, like, if we multiply the equation of the curve, like x square with the whole bracket, can we still solve the equation, like using product rule?
I don't understand what you mean by that. Are you saying if you do what?
And multiply directly using product rule, x square into x plus 3y.
Okay, so you're saying use the product rule of differentiation to differentiate it directly without expanding at first. That's what you
Yes,
mean,
sir.
right?
Yes.
Yes, you can do that. So you can take this as u and this as v dash, and that also works. So you get the same thing.
Okay, sir. Sir, can you do question number 4 of the same paper? It's related to trigonometry identity.
Okay, let me have a look at that quickly. Okay, I'm sorry. Where did that go? June 18, paper 3-2. I'll come back to this in a moment. If it's fairly straightforward, I'll come back to this after I'm done with answering some other questions as well. Okay, so question number 4 or 6?
Question number 4.
Okay, I think this looks fairly straightforward. I'll do this very quickly for you. It's not going to take that much time. Then I'll take some other questions. Fadeen, just give me 10-15 minutes. I'll do separating the variables thing for differential equations after this, and then I'll come to your questions. This is question number 4 from that same paper. Okay. Okay, so we have to prove this identity. Now on the right side, you see you've got sine x over 1 plus cos x. On the right side, there are no double angles here, right? On the left side, you have double angles. So all you have to do is simplify the left-hand side, apply the double angle identities, and you would eventually get the form on the right side. Now, how do you think about it? In the numerator, we have 2 sine x. Sine 2x is going to become 2 sine x cos x, right? In the denominator, you have 1 minus cos 2x. Now, cos 2x has 3 different possible identities. Cos square x minus sine square x, 2 cos square x minus 1, 1 minus 2 sine square x. Okay, so now you need to decide which one of those identities you should be using here. Now, when you have a fraction like this, the idea is you want to somehow try to cancel some things out, try to make things simpler somehow. Let's see which form is going to help us do that. If we use 2 cos square x minus 1, that's going to give us 2 sine x common in the numerator, 1 minus cos x, and then you can have sine x there, 1 minus cos. Okay. Now, since you want something in terms of cos in the denominator, right? You want something in terms of cos in the denominator. So what I'm doing is, because of that, I'm using the form that has only cos in it, right? The final result that you want has to be in terms of cos, right? So that's why I'm using the form that has only cos in it. Now, the other forms would also work. This is, I think, just going to be a bit more efficient in this case because you will directly have only cos terms here. Now, let's see what we get from this. When we simplify this, it becomes 2 sine x minus 2 sine x cos x. So while you do this, you have to think of a couple of steps ahead. Okay, this is what I can do next after this. This is what I can do next after this, keeping the end in mind that you want sine x in the numerator and 1 plus cos x in the denominator. Now, until this point, what I have is 1 minus minus 1, that becomes 1 plus 1, that's 2, 2 minus 2 cos square x. Now we need to simplify things a little somehow. Now, in the numerator, we want only sine x. In the denominator, we want 1 plus cos x. One thing that we notice here is 2 can be gotten rid of if we take this 2 common from the numerator and the denominator. In the numerator, we can also take sine x common. Okay, let's do that. In the numerator, if we take sine x common, that leaves us with 1 minus cos x inside. Okay, interesting. Now we take 2 common from the denominator as well. That leaves us with 1 minus cos square x. 2 and 2 get cancelled. And we have sine x outside here. We've got sine x in the numerator. That's what we wanted. Now the problem is we want to get rid of this 1 minus cos x somehow, okay? Because we do not want that in the numerator. Now, how can you get rid of that? This is 1 minus cos square x. 1 minus cos square x can be thought of as 1 squared minus cos of x whole squared. That's a square minus b squared. This is an identity that you have to use a lot while proving identities. Okay, you have to keep this in mind. You have to use this a lot. Now, this is a square minus b square. What does this become? This can be written as a plus b into a minus b. So what you get from that is sine x into 1 minus cos of x. In the denominator, you have 1 plus cos x into 1 minus cos x. 1 minus cos x and 1 minus cos x, they get cancelled. And you're left with sine x over 1 plus cos x. And that's what you wanted to prove. This is the same as the right-hand side. Okay? Make sense? So that
Okay,
was
sir.
fairly straightforward. It was a standard trigonometric identity, not that complicated. Okay. All right. Now, let me show you a couple of examples on differential equations where you're saying you struggle with separating the variables. Okay, so what I can do is I can just have a look at this worksheet of differential equation, maybe try to figure out if there's one in which separating the variables is maybe a bit more complicated. Okay, let's have a look at this for instance. Okay, so you're saying you're struggling with separating the variables, right? Now, how do you separate the variables here? Let's have a look at this example. The first thing that you need to remember is whichever side has dh in the numerator, you want h terms on that side. Mostly it's dy and dx. In dy and dx, what you would say is whichever side has dy in the numerator, you want all y terms on that side, and whichever side has dx in the numerator, you want all x terms on that side. Okay. Now in this case, dh is in the numerator on the left side, so you want to bring all the h terms on the left side. dt will go to the other side, and it will be in the numerator and on the right side. So all t terms, if they exist, they should be on the right side. Okay. Now, the common problem that students have in problems like these, where you have plus minus coming inside, they'll think of doing something like this. Maybe since they want to take h on the left side, they might start like this, that they take 5 over h squared to the left side. So it becomes dh over dt minus 5 over h squared equals minus 120. And then they kind of get stuck that what do we do after this? And then by mistake, what they do is they try to take dt on the other side like this, but that doesn't work, right? Because dt also has to be multiplied here. And if it gets multiplied there, then there's more confusion, because when you multiply dt with everything here, it becomes minus 5h squared, minus 5 over h squared into dt plus dh, and then minus 1 over 20 into dt. And now you have dt here as well. What do we do with this? So they end up messing up things like this. Okay. What you have to do is, in the very first step, just take dt to the other side. Mostly this works. Okay. In the very first step, take dt to the other side. Okay. Now, if we take dt to the other side, what does that become? 5 over h squared minus 1 over 20 whole multiplied by dt. Now dt is on the right side, dh is on the left side. Now what we want to do is we want to take all h terms to the left side. Now the thing is, when we take h terms to the left side, they should not be adding or subtracting to dh. They should be multiplying or dividing by dh. Okay, they should be multiplying and dividing by dh. You can't take 5 over h squared to the other side and make it 5 over 8 minus 5 over h squared plus minus something. You don't want that. You want dh being multiplied or divided by something. Now, the way to do that here would be that you would take LCM on the right side first. Okay, take LCM on the right side. What does that become? In the numerator, in the denominator, you have 20h squared. Okay, then this gets multiplied by 5, and that gives you 100 minus h squared whole times dt. And now you take this whole thing to the left side. You can't isolate this and take it to the left side. You have to take this whole fraction to the left side now. So we kind of cross multiply here. 20h squared goes to the left side. It becomes 20h squared divided by 100 minus h squared dh. And on the right side, when this whole thing goes to the left side, you're just left with 1. You have 1 dt. And now the variables are separated. You have to integrate the left hand side separately and the right hand side separately. And then you can solve it further. Okay, how do you solve this left hand side, by the way? How do you solve this left hand side? How would you integrate the left side in this case?
So tan.
Partial
Tan.
fraction.
You remember the rule, the condition that we have for tan inverse. For tan inverse, you want constant in the numerator. You do not have a constant in the numerator. Tan inverse rule does not work. Okay, sorry.
Partial fractions, because this is an improper fraction, I think.
It's an improper fraction. You could do both of those things here. It's an improper fraction. You could either do quotient plus remainder over divisor. That could work here. But once you do that, you'll have to do partial fractions after that. In this case, since it's an improper fraction in which the degree of the numerator and the degree of the denominator, they are both the same. The numerator does not have a higher degree. They're equal. Doing partial fractions directly is going to be quicker and easier. So yes, you're both right. What you do is you do partial fractions here. You'll break it down into two parts. You'll say in three parts, in fact, 28 squared over 100 minus 8 squared. Since it's an improper fraction, its form is going to be like this. First of all, you factorize the denominator. Partial fractions are only possible if you can factorize the denominator. In this case, the denominator can be factorized to 10 minus h into 10 plus h, right? You can find the factors. Once you have factorized this, what is going to be the partial fraction form for this? Since it's an improper fraction, you would have an extra constant, a, and then you would say plus b over 10 minus h plus c over 10 plus h. Find the partial fraction for this, and then you integrate each of these three terms separately. You can do that afterwards, right? But that's how you think of separating the variables when you're solving differential equations, okay? Take this denominator to the right side first. It multiplies with the whole thing. And then you think about how you can bring the variable that you want on the left side, how you can bring that to the left side. Okay, does that make sense?
Sir, can you
Yes,
show
sir.
how will we find A?
How will you find A? Finding A is just straightforward like this. What you do is, in simplified form, this is the simplified form where you have 28 square in the numerator. In the denominator, you have 100 minus 8 square. If you write that in the order of decreasing power, so descending power, it becomes minus 8 square plus 100. You can find the value of A directly by just dividing the first terms of the numerator and the denominator. So in this case, A would be equal to 28 squared divided by minus 8 squared, and that gives you minus 20. The value of A would just be minus 20. Once you have the value of A, you would get something like this. Once you've already gotten the value for A, you would have minus 20 here, and then you just follow the normal partial fractions process, multiply the denominator on the left side to the right side, and that gives you 20h. That is identical to minus 20. Remember, this denominator also gets multiplied with minus 20. So you have minus 20 into 10 minus h into 10 plus h plus b into 10 plus h plus c into 10 minus h. Input h equal to 10 ones, input h equal to minus 10 ones. Find the values of b and c, and then integrate each term separately. Okay, you can do that, right?
Yes.
Okay, so
Sir,
that's, yeah.
sir, can you scroll up a bit?
Yes.
Sir, can't we take h square to the numerator to separate it? Then we can bring h square to the other side.
Okay, let me try that and show you why that would not work. Dh over dt equals 5h raised to power minus 2 minus 1 over 20. Okay, what do we do now?
Sir, we can take h to power minus 2 to the other side.
How do you do that? As in, what exact process do we do for that? How does it go to the other side? What would it become on the left side? Yeah.
Sir, 1 over h power minus 2.
Okay, so it's saying it goes to the other side, becomes 1 over h power minus 2.
No, 1 over h power 2, basically, not minus 2.
No, when it goes to the other side, it'll be actually 1 over h power minus 2 because it has to go in the denominator there. The power remains same, but the problem is you can't do this. How do you take this to the left side? You would also have to, when you take something to the other side, actually the idea is that you're dividing the whole thing by that expression. So if you're taking this to the left side and dividing it on the left side, that also means that this term would also get divided by h power minus 2. You would also need h power minus 2 here. You can't just take that to the left side. There's also another term here. You have to divide by h raised to power minus 2, that whole thing, not just the left side. That makes sense?
Okay, sir. Okay.
Yeah. So it would not work. So it's just like saying if you have 5x plus 2, and then on the other side you have x squared equals, so if you have something like this, x squared equals 5x plus 2, you're doing something like this, that you're saying, let's take 5 to the other side and write it as x squared over 5 equals x plus 2. You can't do that, right? If you're dividing by 5, you also have to divide 2 by 5, right? You would also need h power minus 2 here. So it would not work. All right, now let's move on. So this was one example in this. Let me see if I can find another one like this. I'm sorry, what is opening here? Worksheet B3 differential equation. Okay, so we've looked at one such problem already where we had to separate the variables. Yeah, this works very similar to that, right? In this case as well. So generally the problem comes, the confusion comes when you're separating the variables, when you have plus minus like this. In this case as well, if you want to separate the variables, you would first need to take LCM on the right side, take dt to the right, take LCM on the right side first, it will become 4 minus x squared over x. Take dt to the right side, it becomes this. And then take the x terms to the left side, it becomes x over 4 minus x squared dx equals dt. Okay. So yeah, so that's the only problem, that's the only confusion that comes when you are separating the variables and you have plus minus like this. Otherwise, it's not that complicated. All right, now let's have a look at the questions that Ferdeen is asking about. Rukaya, does that answer your questions?
Yes, sir.
Okay. Now, okay. How do we integrate tan square and tan cube? Okay. Tan square is integrated using trigonometric identity. You need to know that. Just like you need to know how to integrate sine square and cos square. They are integrated using the double angle identity for cos, sine square and cos square. Tan square, on the other hand, is okay. I'm sorry, my iPad turned off for some reason, but I think I'm back now. Okay, can you see my screen again?
Yes, sir.
Okay, so how do we integrate tan square x and tan cube x? Let's have a look at this. So first of all, let's talk about tan square. Okay, integration of tan square x with respect to x. Now tan square is integrated using this identity. You need to remember this in case you can't figure it out during exam. You should remember this. Remember the identity that you've got for tan? 1 plus tan square theta. That is identical to secant square theta, right? That's the identity that you have for tan. So what that means is tan square theta can be written as secant square theta minus 1. Okay. So that means we can write this as secant square x minus 1, integrate this thing with respect to x. Okay, tan square can be written as secant square x minus 1. Now, what's the integration of secant square? Integration of secant square is tan. right? The derivative of tan is secant square, integration of secant square is tan. So this becomes tan x. And then what about the integration of 1? That's x. That's how you integrate tan square x. Okay, so it's just a two-step thing like this. That's the integration of tan square x. All right. Now, what about tan
Yes.
cube? How do we integrate tan cube x? Let's talk about that. Tan cube x with respect to x. Walaikum assalam. I've been hearing the STARS exam was actually quite easy overall. Some of my students were telling me actually they will expect to score 45 plus quite easily. So I think it was probably not that difficult, but that's just my assumption. Maybe they'll figure out later if they did any careless errors, but overall the impression is that it was not that difficult. Okay, tan cube x. How do you integrate tan cube? Sine cube, cos cube, and tan cube. They're all integrated using substitution. Okay. For sine cube, we use the substitution u equals cos x. For cos cube, we use the substitution u equals sine x. For tan cube, we just use the substitution u equals tan x. Okay, this is the substitution that's used for tan. Now, how does this work?
Sir,
Yes, Fardeen. So while separating variables, when it's plus minus, we should always take LCM first before taking terms to the other side when you're separating the variables. That's correct. Okay, it's all right. Forget about S1 now. It's done. Now let's just focus on what is still in your control. Let's focus on the remaining exams. Yes, Abdullah.
sir, this substitution will be given in the exam.
In one recent paper, I've seen the substitution for sine cube x was not given. Okay. Generally, it's written in the syllabus. Whenever they ask you to use substitution, they will always give you that substitution in the exam. Okay. That's the general rule. But we teach this every single year, how to integrate sine cube, cos cube, and tan cube. They've generally been giving this substitution in the exam, but in one recent paper, they've not given this. So I would suggest just remember these three substitutions. Okay, nothing else. Just remember these three substitutions. When you have to integrate sine cube x, use u equals cos x. When you have to integrate cos cube x, use u equals sine x. And when you have to integrate tan cube x, use u equals tan x. Just remember these three substitutions. Apart from this, you will always be given when you have to substitute. This will also mostly be given, but sometimes it has happened one time in the past papers that I've seen that they've not given the substitution. Now, one way to integrate that was using a method that's not using another method that's not in the syllabus explicitly, or using this substitution. So yeah, I would recommend that you just remember these three substitutions.
Sir, so can't we just separate the powers like sine into sine square x to
And then
integrate sine cube? Then
what do
we
you do
can
after that?
integrate sine square x separately.
How can you integrate them
Oh,
separately? It's
yes.
a
Okay,
product.
sir. Sorry. Yes.
Product has to be integrated using integrational parts, but if you have both trigonometric functions, they do not simplify, right? You'll keep repeating the same thing again and again. It will not get simplified. That will not help. Okay, so this is the substitution that we use for tan cube. U equals tan x. Now, how do we use any substitution? We find the derivative of this, du over dx. What's the derivative of tan? That is secant square x. Okay, now we make dx the subject. Dx becomes du over secant square. Now let's just put the substitution there and see what that gives us. Let's replace tan cube with u cube. Okay, and then we have du over secant square x. Okay, now the problem is we need to get rid of this somehow as well. Secant square, how do you do that? Secant square is the same thing as 1 plus tan square. So this becomes du over 1 plus tan square x. And now we can do that substitution again, u equals tan x, right? And that will convert everything to something in terms of u. You have u cube over 1 plus u squared du, and now we can do this integration. How do you integrate this? It's an improper fraction. How do you integrate improper fractions? When the degree of the numerator is more than the degree of the denominator, you have to use long division to divide it into two parts, quotient plus remainder over divisor. That's what we do here. We say u cube, let's divide that by u square plus 1, write this in order. U square plus 0u plus 1, right? U square into what is going to give us u cube? U into that whole thing, that is u cube plus 0u squared plus u, change the signs, minus, 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 this gets cancelled, and we are left with minus u, and that's the remainder. Okay, this is the quotient, and this is the remainder. Now, what does that mean? This integral can be written as quotient, which is u, plus remainder, which is minus u, over divisor, which is 1 plus u squared. And now you can integrate this with respect to u. What's the integration of u with respect to u? That will be u square over 2. What's the integration of this thing? This can be integrated using the ln rule. You can say this is integration of u over 1 plus u squared with respect to u. The derivative of the denominator is 2 times u here. You multiply the numerator by 2, divide by 2 outside to balance that. And now this becomes u square over 2 minus 1 over 2 into ln of 1 plus u squared. And now you put that substitution back, and it becomes tan square x over 2 minus 1 over 2 into ln of 1 plus tan square x. That is the integration of tan cube x. If you want, you can convert this to secant square as well now. 1 plus tan square, that is secant square, but it's not necessary. You can leave it like this as well. That is how you integrate. That's how you integrate tan cube. Is that okay? Any problems with this?
No, sir.
So for odd powers, you have to use this integration. Position of numbers, 1, 2, where does that lie in isolate? Well, numbers you use when you're integrating ln and tan inverse. Remember, when you're integrating ln of something, for instance, or when you're integrating tan inverse, these integrations you need to remember they are done using integration by parts. Okay, now how are they done using integration by parts? They are not products. Integration by parts is used for products. You write this as a product. You say ln of x can be written as 1 into ln x, and tan inverse of x can be written as 1 into tan inverse of x. And now it's treated like a product. And what you do is, when you use isolate here, in the first case, you have a log function. In the second case, you have an inverse trigonometric function. What about 1 and 1? 1 is treated like an algebraic here. Why? Because we can say 1 is the same thing as x raised to power 0, right? 1 is the same thing as x power 0. So we treat that as algebraic and isolate. So what we do is we treat ln and tan inverse as u in these cases, and 1 as v dash, and then we can integrate it. Okay. Is that all right? Does that answer your question? Okay, now some other important integrations that you need to remember that they have started testing in some recent papers. They did not used to be tested before, but now they've started doing that. Let me show that to you quickly here as well. P3 integration. Yeah. So in the formula sheet on the differentiation page, you have these rules given for differentiation. You will not find many questions on this in past papers, but in last couple of years, I've seen at least one. And that means it can potentially be tested. So you need to understand this as well. Now, let me explain what I mean by that. So what you have in some recent papers is, these are the rules that are given in the formula sheet. Okay, these are the rules that are given in the formula sheet. This is f of x and this is f dash of x. These rules are given on the differentiation page, that the derivative of secant is secant x tan x, derivative of cosecant x is minus cosecant x cot x, derivative of cot x is minus cosecant square x. Again, these are also not tested very frequently, so a lot of students end up not knowing them. Okay, but it's important to remember these rules as well. They're given in the formula sheet. You should be able to use them. Now, how do you use these rules? Like for any other rule, the generalized form for this rule would be if you have secant of something, secant of anything, the derivative of that is going to be secant of that using this rule into tan of that thing, and then multiplied by the derivative of whatever that is. Okay? Just like if you have e raised to power, or that's a very simple example. Let me use sine x, for instance. Derivative of sine x is cos x. But if you have something else instead of x there, if you have sine of any expression, derivative of that is given by cos of that expression into derivative of that expression. That's what the derivative of sine is given by. So similarly here, the rule given in the formula sheet, if in that rule, x is replaced by anything else, you'll apply the rule as it is, but do one extra thing at the end, and that will be that you multiply by the derivative of that thing. Okay? Now, similarly, if you have, yes?
Sir, will we differentiate only the x power inside tan or both secant or tan?
We are differentiating this, not these. X is coming only once here. Okay? So we'll only have to multiply it by multiply it once, not twice.
Okay, sir.
Okay. Similarly, if you have cot of something, what's the derivative of that? That is given by minus cosecant square of that thing multiplied by the derivative of that. Okay, let me give you an example. So if you have a function which is 5/3 into cosecant of x square plus 2, what's the derivative of that? Dy over dx. 5/3 remains as it is. Derivative of cosecant, that is given by minus cosecant into cot. So it becomes minus cosecant of this same expression, which is x square plus 2, into cot of this expression, which is again x square plus 2, into derivative of x square plus 2. What's that? That's 2x. This is going to be differentiation of this thing. All right. Now, these are rules that are given in the formula sheet on the differentiation page. Now, they also expect you to be able to do integration of these functions. And these rules are not given on the integration page then. Okay. And you have to figure them out using this differentiation page directly. How would you do that? Now, you might have a function like this given, for instance. Or in fact, what we can do is we can make the corresponding integration rules from this, just like we make rules for the other functions. If these are the differentiation rules, we can write down integration rules from this. They are not given in the formula sheet. We can write down these rules directly from the differentiation page. We can say integration of secant, I'm using the first one right now, integration of secant of ax plus b. Remember, in integration, it's a condition that the expression inside has to be linear, just like for all the other functions. The rule says whatever x is replaced by, that has to be linear. If it's not linear, then you can't use this rule directly. You'll have to do something else. Secant of ax plus b into tan of ax plus b, if you want to integrate this with respect to x. Now, how would you do that? Integration of secant into tan is what? Secant. So this is going to be given by secant of ax plus b. But then you have to divide by the derivative of the expression inside. What would that be? You divide it by a. And that's the result that you get from this. Okay. Similarly, for the other functions, for the last one, for instance, minus, or in fact, in this case, the rule can be written in terms of cosecant only. Cosecant square of ax plus b, if you want to integrate this, what does that become? Integration of cosecant square is going to be minus cot. Minus cot of ax plus b, then you have to divide by the derivative of ax plus b, which is a. And similarly, the rule for cosecant into cot becomes cosecant into ax plus b into cot of ax plus b. Integration of this, that is going to be given by minus cosecant of ax plus b divided by a. These are the integration rules that you have for these functions. Okay, just reverse differentiation. Okay, you're given the differentiation rules in the formula sheet, but these integration rules are not given. So you need to be able to figure them out yourself. Okay, and use them like this. And you will see questions like this in recent papers where you have to use them. For instance, if you want to integrate something like this now, integration of secant of 2x, I think this is exactly what has come in a recent paper, something like this, secant x into tan of 2x, you want to integrate this. Now, you don't have to jump to integration by parts, thinking that it's a product, so you have to use integration by parts, because that is not going to work. It's going to complicate things a lot. This is a rule that you directly have from here. Secant into tan, what's the integration for that? Integration for this is secant. However, then you have to divide by the derivative of this thing. That is going to be 2, and that's what your integral turns out to be here. Is that okay? Similarly for the rest of them. The x
Yes,
parts
sir.
will need to be same here. So they can't ask you to integrate something like this. Secant of 3x into tan of 2x. Well, they won't ask you to do this. If they ask you to do this, then you are in trouble. But if they do, you'll have to use integration by parts and see if that works. I don't think it's quite going to give you anything useful. Most likely they'll give you some hint of how to deal with this. Okay, but eventually you have to use integration by parts here in this case, or you can try expanding this somehow, making the angles the same, but it's going to make things very complicated. Okay. But you'd have to use integration by parts in that case somehow. Okay. So these expressions inside, they have to be the same. Yes. So this thing and this thing, they have to be the same. This thing and this thing. For using these rules, those expressions have to be the same. Okay. No problems. So these are rules that you need to know about. What if they don't give linear? Again, you will not be expected to do that directly then. So if it's secant of 2x squared plus 1, into tan of 2x squared plus 1. If the part inside is non-linear, then you can't integrate using these rules. These rules only work if that part is linear. The only exception would be if you had something like this multiplying outside, x or 2x or 4x or 8x, some expression inside in terms of x multiplying outside, then you could do this integration. But even then, they would not expect you to be able to do this directly. They will give you a substitution to use. So if you get something like this, they will ask you to use a substitution like this, perhaps u equals 2x squared plus 1. They'll ask you to use this substitution. And then, so it could be u equals 2x squared plus 1. It could be u equals 2x squared. One of these, using one of these substitutions, then you can integrate this. But you can't do it directly like this. If you had something non-linear there, they would give you a substitution for that. Okay. Anything else? Anything else? November 2023, we're into. Okay, I might have done that question somewhere here. I think this was the question I was talking about, for which you would need to know that substitution. November 2332. Yeah, so I think this is the one that you're talking about. This is the only question that I've seen in the past papers that requires you to use the substitution yourself. There's another method as well, but that's not explicitly part of your syllabus as such. So these are three substitutions, as I said, that I would recommend that you remember: integrating sine cube, integrating cos cube, and integrating tan cube. Okay, so in this case, you end up getting a sine cube here, and that kind of works. In this case, I think another method might work. When I tried it the first time, there was some careless errors, and then just binned that and did not actually try that again. But I'll actually try this again using another method, and that's basically this one, where you make a loop like this. I'll show you that idea here. Should be integration by parts. Yeah, integration by parts. Yeah, so this is the idea. Sometimes what happens is it becomes a loop like this, that the integral that you started from, you end up getting that same integral at some point after applying integration by parts twice. And then you replace it with that initial integral and make I the subject like this. Some questions you can do using this method as well. It's a method that, again, is not explicitly part of the syllabus, but it makes things simpler in some cases. It's a further maths method. But this also might work in this case. I haven't tried that again. The first time we did that, I ended up making some careless error, and then we switched to this method using substitution. But that could be another idea that could be tried here. But you can look at the solution. This is how I did it the first time, using the substitution. Okay, no further problems. Those of you here in the Zoom meeting, no other questions.
No, sir.
Okay, so what I'll do is I will have a look at all the papers that we have done until now from 2020 to 2024, and use basically filter out the questions that are relatively easier and make some videos on the difficult questions on the different topics that we have. I end up making it too late for most of you to benefit from them, but I'll try this time that I can post most of them by early tomorrow, and not delay them until the night before exam. So what I'll do is I'll try to make the more important ones, as in the more difficult ones first, like integration, complex numbers, vectors questions sometimes also end up being difficult in recent papers, and then differentiation, differential equations. So some of these topics, I might start from them first, so at least you have those available. And then maybe I'll have a look at some of the others as well. Okay, so if you guys don't have any questions, let me have a look at the YouTube chat quickly, if these guys have any problems. Winter 2013, paper 3-2. Okay. Let me see what this is about. Okay, which question from that? Which question from this paper? Walaikum assalam. Okay, the iteration one. Okay, I missed that part. Well, these first parts are mostly circular measure. That's supposed to be a paper 1 concept that should not be a problem for most of you guys. In fact, not even paper 1. It's an O-level concept mostly, as in mensuration problem. It's just that you have some variables involved here, some letters involved here, but the concept is the same, that you have to find an area, subtract some other area from that, or find some lengths using trigonometry. It should not be a problem for most of you who are in A2 now. But for some reason, a lot of people find this quite complicated. Okay, so let's see what we have to do here. In this diagram is a point. So what do I recommend for this? Well, the recommendation is just review your paper 1 concepts again. Remember, anything that is part of your paper 1 syllabus, it can be tested in paper 3 as well. Okay, anything from paper 1 can be tested in paper 3 as well. Circular measure comes very frequently in iteration. You sometimes end up getting a sequence concept as well, and then trigonometry, differentiation, integration. Of course, you're supposed to know anyway. Somebody was asking me a couple of days back about whether you may have to find areas or areas of volume of revolution. Well, of course, that just means that you haven't done enough integration practice for paper 3, because anything that you have done in paper 1, differentiation, integration, trigonometry, even some function concepts, sometimes quadratics, of course, coordinate geometry, all of those concepts you still need to know them. Apart from maybe binomial, you might not need to use that anywhere, but still that can also be tested. But otherwise, all the other topics, you still need to know about them. You can be tested on anything, okay, from paper 1 as well. That's supposed to be a prerequisite for paper 3. Complex numbers, I made one last year as well. You can have a look at my channel if you can find that there. Let's search that for you quickly. I think I made one for complex numbers last year, but then it turned out that the exam got cancelled and I did not make many others after that. Let me see if I can find that right now. Complex numbers, difficult past paper questions. Yes, I can find that here now. Yeah, this is that video. Complex numbers, difficult questions. I'm not sure if these are from recent papers or from topicals, but here's the link. I've just posted that in the chat. Okay, now let's have a look at this quickly. It says in the diagram, A is a point on the circumference of a circle with center O and radius R. A circular arc with center A meets the circumference at B and C. Okay, at A, if you have the center, you have this arc that's meeting the circle in B and C. This is an arc. The area of the shaded region is equal to half the area of the circle. Okay, I missed one sentence there. The shaded area bounded by is bounded by the circumference of the circle in the arc with center A, joining B and C. Okay, you can see that there. The area of the shaded region is equal to half the area of the circle. Now, this is the line that is actually going to help you make an equation. Area of the shaded region is equal to half the area of the circle. Okay, area of the shaded region is equal to half the area of the circle. This is going to help you make an equation. Okay, और फिर उसको आप जो है वो rearrange करोगे, you'll get this thing eventually somehow. Now, how can we do that? We know the area of the circle, or do we? Yeah, so center O is point O is the center of the circle, and we know that the radius of the circle is R. So we know the area of the circle. Area of the circle is just pi R square. So all we have to do is find the area of the shaded region, multiply that by 2, and equate that to pi R square. And then eventually we should get something like this. Okay, now how do you approach this? How do you find the shaded area? Okay, now we'll have to break this figure down into parts somehow. Now, one part that you can start from is you can say this is a sector. You can find the area of this sector. Okay, you can find the area of this sector somehow. Once you've got the area of this sector, you still have some part of the shaded region left, and that's this part here and this part. These are two segments, and they are coming from this sector. If you think of this sector, in this sector, if you subtract this triangle, you would get that segment. So all you have to do is break your figure down like this into parts. Okay. And then find those individual areas, add them up together, multiply them by 2, and equate them to pi R square. Let's try that quickly. How do you find the area of the sector, first of all? What information do we have? Area of sector is given by half R square theta. So we need two things. We need the radius, and we need the angle. Now, if this is R, that's the radius of the circle. That means this is also R, right? And this is also R. So these are isosceles triangles. This triangle is an isosceles triangle. Two sides are R, and then the remaining side, what's that? This is theta. In fact, I think we can break it down even further, or just do it like this. In fact, if you have to find the area of the, yeah, let's do it like this. So if this is R, we can say this is focused on this triangle on the left side. This is an isosceles triangle. Okay. Now, in isosceles triangles, you need to remember that property. If you break the triangle down into two parts like this, it makes a 90 degrees here. If you do not use this, you end up using cosine rule, and that's going to complicate things for you. Avoid using cosine rule as much as you can, because you end up getting square roots from that, and they're hard to simplify. Try avoiding that. Generally, when you have an isosceles triangle, this is one thing that you should always do. Break that isosceles triangle into two parts like this. Okay. This is going to be the midpoint of AB. And now you have a right angle triangle. Now that you have a right angle triangle, what you can do is you can find the length AM somehow. How can you do that? Use this right angle triangle. So always break isosceles triangles into two parts like this, making a right angle such that this line coming from O, for instance, is making a 90 degrees here at the midpoint. Now, can you find the length AM somehow? AM is the base, R is hypotenuse, AM over R, that is given by cos of theta, right? Cos theta equals AM over R. So now you can say AM therefore equals R cos theta. Now if AM is R cos theta, what about AB? AB is going to be twice that. So AB equals 2R cos theta. And that is the radius of this yellow sector that we've got here. That's the radius of the sector. Okay. Now, once you have the radius of that sector, since you want your answer in terms of theta, now you say if this is theta, this is also theta. Right? Why? Because this is also R and this is also R. Right? So these are like congruent triangles. So this is also theta. What's the area? What's the angle of the sector now? 2 theta. Radius is 2R cos theta. This is the radius of that sector. Angle of the sector is 2 theta. So what's the area of the sector now? Area of the sector A, B, C. Let's figure that out. Or BAC. We'll call it that maybe. Yeah. Area of sector BAC. How can we find that? That's half R squared theta. What's the radius? This is the radius, 2R cos theta. So we say 2R cos theta whole squared into the angle. What's the angle? The angle is 2 theta. So multiplied by 2 theta. Now let's simplify this. 2 and 2 get cancelled. And we have 2 squared, which is 4. And then R squared from here. And we have theta from here as well. 4R squared theta into cos squared theta. That's the area of the sector BAC. Now leave it here. That's the area of the sector that we found. Now, what's the next thing that we need? We need the area of one of these segments, either this or this. They're both equal, right? So find any one of them. Let's find this one on the right side. Let's use this sector for that. Area of that segment is going to be area of sector minus the area of triangle. Now, for that, we need this angle somehow. Now, how do you find that angle? This is an isosceles triangle. It's an isosceles triangle, right? Okay, now we actually have to use some trigonometry here as well, some trigonometric identities. Maybe that's what's confusing you. And that's what makes it, I think, a bit more complicated. This angle is theta. If this angle is theta, this is also theta. It's an isosceles triangle. If these two angles are theta, what about the remaining angle? What would this be? What's this angle? This angle is going to be pi minus 2 theta. Okay, this is pi minus 2 theta. Now, what's the area of that sector? Let's write that down. Area of sector, what are we calling that sector? This is AOC. Area of sector AOC, half R squared theta. Half R squared, radius is R, into angle. Angle is pi minus 2 theta. Okay. Now, area of triangle, you can do this all in one single step as well. I'm just using a bit more steps and let's make it shorter. I can say area of that segment that I shaded there, that is equal to area of the sector AOC minus the area of the triangle AOC, right? Area of the sector AOC and minus the area of the triangle AOC. What does that give you? That gives you half R squared into pi minus 2 theta minus triangle AOC. How do you find the area of the triangle AOC? You know two lengths, R and R, and you know the angle between them. That's pi minus 2 theta. This area becomes half into R into sine of pi minus 2 theta. And that's what makes it slightly more complicated. If you know this identity, you can actually write it as sine 2 theta. Sine of pi minus 2 theta is the same thing as sine of 2 theta. Okay, if you don't understand that, one way to do that is apply compound angle identity on this. Sine of A minus B, what's that? That's going to be sine of A into cos of, sine of A into cos B minus cos of A into sine B. So this can be written as sine pi into cos 2 theta minus cos 2 theta into sine pi. Now, no, sorry, I have done something wrong here. Sine A cos B minus cos A sine B minus cos pi into sine of 2 theta. Sine pi is 0, so it becomes 0 minus cos of pi is minus 1 into sine of 2 theta. And that gives you sine of 2 theta. So sine pi minus 2 theta, this can be written as sine of 2 theta. So if you understand that, you could actually write this thing as 1 minus 2 r squared into sine of 2 theta directly. And that is what the area of the segment becomes. Now, this is one way to do it. If you find it too complicated, converting sine of pi minus 2 theta to sine of 2 theta, another way could be that to find the area of this triangle, you break it down into 2 parts. You have already found this length. You know, this is what? This is 2r cos theta or r cos theta. You know, this length is r cos theta. So you could use this angle theta along with r and r cos theta, find the area of this half triangle, multiply that by 2, that will give you the area of this full triangle. And that could be another way of doing that. That will give you the same result as well, if you don't want to use that identity. Okay, I hope that makes sense. Now, we've got the area of the segment as well. Now, that's the area of one segment. What about the area of 2 segments? We can just multiply this whole thing by 2. The 2 multiplied by this whole thing, 2 into this whole thing, and then 2 into this whole thing. What does that give us? This gives us r squared pi minus 2 theta minus r squared sine of 2 theta. That's the area of the segment that we get. Now, once we've got the area of the segment, we add the area of these 2 segments with the area of that sector that we calculated earlier. Let's see what we get from that. The shaded area, what's that? 2 times the shaded area. 2 into r squared into pi minus 2 theta minus r squared sine of 2 theta plus area of that sector that we found earlier, to 4r squared theta into cos squared theta. That's 2 times the area of the shaded region. This should equal area of the circle. So we equate this to pi r square. You should never touch those questions in the middle. If you have started and you realize it's getting a bit too long, move on, but do not skip the whole question. These are free 3 marks. Don't skip that. Okay, don't skip this one. Not always. This is not all complicated. It's not always that complicated. Sometimes it's very quick. So have a look at this. If you think it's too complicated, then skip that. Sometimes it's very straightforward as well. So you have to make that decision at that point, whether you think you can figure it out quickly or not. Okay, now 2 into shaded area, that becomes pi r square. Pi r square equals 2 into this whole thing. Now you see you have 2r squared into pi minus 2 theta minus 2r squared into sine of 2 theta plus 8r squared theta into cos squared theta. Now r squared is appearing in every single term. That will get cancelled eventually. Why? Because we can take r squared common, divide that by the whole thing, divide the whole thing by that, and this is what we get. And now we look at what we want at the end. So at the end, what we want is we want to have cos 2 theta on one side, pi on the other side, sine 2 theta on the other side. Okay, so keep that in mind. You want to make cos 2 theta the subject. Do you have cos 2 theta here? Yes, we have cos square theta. We don't have cos 2 theta. Now we'll figure out what to do with that. 2 pi minus 4 theta minus 2 sine 2 theta. Okay, so we have sine of 2 theta, but we don't have cos 2 theta. We'll do something about that. Okay, so we have pi equals 2 pi minus 4 theta minus 2 sine 2 theta plus 8 theta into cos square theta. Now, since we want cos 2 theta, now you need to think of that identity. Cos 2 theta equals Cancel 2 on both sides. Well, we don't have. Okay, so if you mean, no, we had to equate 2 times shaded area with pi r square. That's why I wrote there. That's why I wrote that there. Okay, now what were we doing? Yeah, so let's convert cos square to cos 2 theta. How do you do that? We have this identity for cos 2 theta. Cos 2 theta is given by, it's given in the formula sheet, 2 cos square theta minus 1. So that means if you make cos square theta the subject, that becomes 1 plus cos 2 theta divided by 2. And that's what we write here. We say instead of cos square theta, we write 1 plus cos 2 theta whole divided by 2. Okay, using that identity, this is the identity that you have to use for integrating sine square and integrating cos square as well. That's something that you need to remember. You always have to use that identity for integrating sine square and cos square. What does that become now? 8 and 2, they get cancelled, and you have 4 here. Let's simplify this. And now we have 0 on the left side. Let's bring this pi to the right. It becomes, in fact, we want minus pi there. Let's take it to the left side. I'm taking this to the left for now. We'll see what happens to the rest of them. In fact, I'm taking all of these terms to the left side because in the final result that we want 4 theta in the denominator there. That will come from there. And these terms here. Okay, all right. Let's simplify this first and see what that gives us. Okay, pi equals 2 pi minus 4 theta minus 2 sine 2 theta plus 4 theta plus 4 cos plus 4 theta cos 2 theta. We're almost there now. Minus 4 theta and plus 4 theta, they get cancelled. We need to make cos 2 theta the subject. Take the rest of the terms to the other side. And that is going to give you, when this goes to the other side, that becomes 2 sine 2 theta. And this goes to the other side, pi minus 2 pi, that is minus pi. And what are we left with? That equals 4 theta into cos of 2 theta. Divide 4 theta on the other side, and we have cos 2 theta equal to 2 sine 2 theta minus pi divided by 4 theta. And that is what we had to prove there. Now, pretty long, but in terms of concepts, there was nothing that you did not know already, right? These are paper 1 concepts. Apart from maybe, yeah, this identity. But apart from that, this is all P1. So this was, yes, a more complicated type of question here. But sometimes it's a lot easier than this. You get better at it with practice. So since you don't have a lot of time left now for practice, at least do this much. Look at the questions like this and think in your head what area you need to subtract from what area, and which area you need to add to which area to figure out the final result. But that's how you basically would do that. So what would you do in an exam now? Once you're done with maybe a few steps here, for example, finding the radius of the sector, that was pretty straightforward. Finding this much was pretty straightforward. And then as soon as you realize, okay, it's becoming a bit more complicated, a bit too complicated, what you can do is you can just skip this part, do the rest of the paper, and come back to it at the end. But not always, sometimes it's not that difficult. So I would suggest have a look at it, see if you can figure it out in a few minutes, 2-3 minutes, as in if you start going in the right direction and you think you're getting closer to the final answer, just do it right now, right at that point. Because what happens is when you come back to it at the end later, what you also have to do is you have to read the question statement again. So if you can figure it out the very first time, just go ahead with it and complete it. But if you think you're getting stuck for a bit too long, maybe more than 3-4 minutes, then stop, move on to the next one, and then come back there. Yes, of course, you have to remember the integration of sec and x tan x. We were just talking about that. These are the differentiation rules that you are given in the formula sheet. You just reverse them to make the corresponding integration rules. And then if you have something else instead of x here, some other linear expression, you have to divide by the derivative of that, just like we do for other rules. We have to remember this, yes. Okay, so I think that's it. We will end this here, and I'll see you again tomorrow. Tomorrow we'll have a long session. I'll do 2 sessions tomorrow, one with my Zoom class and one on YouTube as well, inshallah. If you have any last minute questions tomorrow, we will have a long session to discuss them tomorrow, inshallah. June 21, November, June 21, 3-2. What I'll do is I'll just show the solution to you quickly. If I have it solved somewhere, then I'll have to end this. We'll have a longer session tomorrow, inshallah. June 21, 3-2. I'll be posting a lot of videos on difficult questions from recent papers overnight and tomorrow, inshallah. You can have a look at them as well if you found the S1 and M1 videos helpful earlier. Tomorrow I'll have a session with my Zoom with my past paper session students around 5:30. That will just be streamed live. I'll be taking mostly their questions, and then I'll have a YouTube live session around, I think, just after Maghrib, 7:45 or something, 7:45, 8 p.m. Inshallah. June 21, 3-2. Okay, both will be streamed, but I'll be taking more questions on Zoom in the first session, and then the second one will only be for YouTube. What's the question number? Vector's question answer. Let me see if I can find that here. Vector equation for line through A and B, that's straightforward. And then this is equal. Okay, this one. You just have to find the length of OP and equate them here. And that's it. Yeah, it was different, but not that complicated. You just find the length OP and equate it, find 2 values of lambda. That's how you would do the part C, if that's what you're asking about. Wrong paper? Okay, sorry about that. That was June 21, 3-2. Okay, sorry. That's October, November. June 21, 3-2. Okay. Length equal show करनी है आप angle find करना है. Okay. Yeah, this does look a bit complicated because of the ratios. Yeah. Okay, so I can just show you the solution right now because I need to end the session. And the time for Maghrib is running out. I'll just show this to you. And then maybe tomorrow we could discuss some more of them. I'll include the explanation for this and that vectors difficult questions video as well. I'll be working on some of these videos tonight, inshallah, and hopefully post most of them by afternoon tomorrow, inshallah. All right. Okay, all right. I'll see you again tomorrow. Allah Hafiz.
Allah Hafiz, sir.
Allah Hafiz.